Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. What are some key benefits of using Spatial SQL compared to traditional database queries?
Spatial SQL offers several key benefits compared to traditional database queries. One of the main benefits is that it allows for faster and more accurate spatial analysis. Imagine you have a big puzzle with pieces scattered all around. Spatial SQL helps you quickly analyze and put together these puzzle pieces to see the bigger picture much faster than traditional methods. Another benefit is that Spatial SQL supports spatial applications. This means that you can create maps, visualize data in a spatial context, and build location-based services more efficiently. It's like having a special tool that helps you navigate and explore a treasure map to find the hidden treasures in the data. Additionally, Spatial SQL enables spatial data science and machine learning, just like how you can use tools to learn about dinosaurs from their fossils. Spatial SQL allows you to extract valuable insights and patterns from spatial data to make informed decisions or predictions. Overall, Spatial SQL breaks down the walls between traditional database queries and spatial data, providing a powerful and versatile tool for geospatial analysis, application development, and advanced operations like spatial modeling and machine learning.
How does Spatial SQL facilitate cross-functional collaboration and the ability to work with large-scale data?
Spatial SQL facilitates cross-functional collaboration by allowing teams that traditionally worked in silos like GIS, analytics, data science, and business intelligence to easily share and collaborate on data. It enables different teams to use the same language, SQL, to access and analyze both spatial and non-spatial data. This means that non-spatially focused teams can share their data with GIS teams and vice versa, breaking down the traditional barriers between different departments within an organization. When it comes to working with large-scale data, Spatial SQL offers a significant advantage in handling massive datasets efficiently. For example, it allows users to perform operations like spatial joins on millions of data points, such as taxi pickups in a city and census block groups, compared to traditional GIS tools, which may struggle with large volumes of data. Spatial SQL can process and analyze vast amounts of data much more quickly and effectively. This capability makes it ideal for dealing with big data sets and performing complex spatial analyses without experiencing performance issues.
How do popular tools like PostGIS and SpatiaLite contribute to the use and implementation of Spatial SQL in practice?
Popular tools like PostGIS and SpatiaLite play a crucial role in the use and implementation of Spatial SQL in practice. They act like special helpers that make Spatial SQL even more powerful and versatile. Imagine you have a magic wand that helps you build a beautiful sandcastle at the beach. Similarly, PostGIS and SpatiaLite are like magic tools that help users work with spatial data in databases more effectively. They provide extra functionalities and capabilities specifically designed for handling spatial information within SQL queries. For example, PostGIS and SpatiaLite allow users to perform advanced spatial operations like measuring distances between locations, finding points within a certain area on a map, or determining the intersection of different geographical shapes. These tools essentially extend the basic capabilities of regular SQL to include specialized functions for manipulating and analyzing spatial data. So when users work with spatial databases using tools like PostGIS and SpatiaLite, they can take advantage of these additional features to perform complex spatial queries, create spatial visualizations, and derive valuable insights from geographical data more efficiently. In a way, these tools make Spatial SQL more practical and user-friendly for tasks that involve location-based information.
How do data warehouses like AWS Redshift, GCP BigQuery, and Snowflake enhance the capabilities of Spatial SQL by offering native support for geometry data types, and built-in spatial functionalities.
Data warehouses like AWS Redshift, GCP BigQuery, and Snowflake enhance the capabilities of Spatial SQL by providing native support for geometry data types and built-in spatial functionalities. It's like having special tools in your toolbox that are specifically designed for working with maps and locations. This means you can store and analyze spatial data more efficiently and accurately within these data warehouses. So, when you use Spatial SQL in these studies, you have access to features that are tailor-made for handling geographic information, making it easier to work with maps, locations, and spatial relationships.
That's very interesting. How does the support for geometry data types in data warehouses like AWS Redshift, GCP BigQuery, and Snowflake contribute to the performance and scalability of spatial queries in Spatial SQL?
Having support for geometry data types in data warehouses like AWS Redshift, GCP BigQuery, and Snowflake is like having special tools in your toolbox that are designed specifically for building complex structures with Lego blocks. These geometry data types allow these data warehouses to understand and handle spatial information, such as points, lines, and shapes, in a way that regular databases cannot. This specialized support means that when you run spatial queries in Spatial SQL, the data warehouses can process and analyze this spatial data more efficiently and accurately. Because the data warehouses can speak the spatial language with these geometry data types, they can perform operations like finding distances between locations, overlaying maps, or identifying spatial patterns much faster and on a larger scale. This support enhances the performance and scalability of spatial queries, making it easier to work with and derive insights from spatial data within these studies.
That's a fascinating analogy. How does the built-in spatial functionality in data warehouses like AWS Redshift, GCP BigQuery, and Snowflake streamline the process of spatial analysis and data manipulation using Spatial SQL?
The built-in spatial functionality in data warehouses like AWS Redshift, GCP BigQuery, and Snowflake can be compared to having special tools in your toy toolbox that help you build amazing toy structures. These tools are like magic wands that make it much easier for you to work with special toys that have different shapes and sizes. These data warehouses with spatial capabilities allow you to store and manage spatial data more effectively. It's like having a super organized toy storage room where you can quickly find and play with specific toys whenever you want. When it comes to spatial analysis and data manipulation, using Spatial SQL, these built-in features act as powerful assistants. They provide special functions and commands that understand spatial relationships and can perform tasks like measuring distances between locations or finding all toys within a specific area. In simpler terms, these spatial functionalities streamline the process by providing shortcuts and special abilities to analyze and manipulate spatial data more efficiently. It's like having a magical map that not only shows you where different toys are, but also helps you figure out the best way to play with them.
That's a creative way to explain it. How does the interoperability between GIS and other areas of an organization benefit from the use of Spatial SQL, especially with the support of tools like PostGIS and data warehouses?